All right, let's crush another Mtel question. This one says, use the diagram below to answer the question that follows. We've got this kind of sun-looking image. It says the diagram above was created by adding isosceles triangles to the sides of a regular octagon. What is the measure of angle Z, which is labeled here? So we're given enough information to figure out all of the angles around angle Z. So what I'm going to try to prove is that we know this angle, which are going to be equal to each other because these are all the same triangle. All these triangles on the outside are equal, and we're also going to be able to figure out this interior angle here, which is maybe the hardest part of this. And all four of these angles are in a circle with each other, so they are going to add up to 360. So if we can figure out the measure of all these angles, we'll be able to figure out Z, and that's exactly what I'm going to try to do. First off, we can figure out these corner angles because this is an isosceles triangle, so these two sides are going to be the same, which means the base angles are also the same. And we know that all of the angles in a triangle add up to 180, so if we call these little angles x, we can develop an equation where all of the angles add up to 180. So we know that 72 plus x plus another x has to equal 180. So 72 plus 2x equals 180. After I subtract the 72 over, we get 2x equals 108. So that x angle is going to equal 108 divided by 2, which is 54. So both of these angles are 54. Now we just need this interior angle of a regular octagon. Well, there's a formula for finding the interior angle of a regular polygon, and that looks like this. It's 180 times n minus 2, and all of this divided by n. So this is the equation, if you can remember this, for calculating the interior angle of any regular polygon with any number of sides. What this means is that every time you add a side on a polygon, you're adding 180 degrees to the total of the interior angles. So a triangle, the interior angles in a triangle add up to 180. The interior angles in a square add up to 360. So we added a side, we add 180. If you want to find one of the interior angles, at the end you're going to divide the total sum of all of the angles by the number of angles in that shape. So in this case it's 8. So when we plug in the number of sides here, we do 180 times n minus 2. So number of sides is 8 minus 2 is going to end up being 6. We multiply that by 180 to give us the total sum of all the angles on the inside, and then we divide that by the number of angles to find the angle measure, and n is 8 in this instance. So 180 times 8 minus 2. 8 minus 2 is 6 times 180 ends up being 1080. So that's the total sum of all of the angles on the inside, and then we're going to divide by 8 to find the measure of that interior angle, which ends up being 135 degrees. And then finally, we know that all of these angles add up to 360, so we had 154 plus another 54 plus 135, which is what we just found for the interior angle, and then plus our z is going to equal 360. So 54 plus 54 plus 135 is 135 plus 108, which is 243, plus z equals 360. I'm just going to subtract that 243 over to find z, which gives us 117, and that is answer C.